Hello learners and welcome back to VLSI Simplified. In our previous video, we explored the basics of Verilog data types like signals, trends, values and how they behave in simulation. Now, it's time to go a bit deeper. So in this video, we will focus on different types of nets in Verilog, including wire, wire OR, wire and trireg. We will not just understand what they are, but also how they behave with multiple drivers and how they resolve conflicting values. We will even simulate these scenarios using ModelSim so you can visualize what's happening in the real time. So let's get started with a quick overview of what you will learn in this video. So in this video, we are going to explore the core net types in Verilog, the signals that connects different parts of your digital circuit. We'll start by revisiting the purpose of nets and how they differ from variables. Then, we will break down 4 key net types. That is wire, the most commonly used net for point-to-point connection. Then wire OR and wire AND, which helps resolve multiple drivers using logical OR and AND respectively. And trireg, a special kind of net that remembers the last driven value, which is useful for simulating bus hold behavior. And by the end of this session, you will clearly understand how each of these net types behaves in both theory as well as simulation. And yes, we will wrap up with the ModelSim demonstration so you can see these concepts come to life. Alright, this is VLSI Simplified. Let's get started and let's simplify.
Like a Hellcat.
Now that we have seen how signals behave, let's talk about how Verilog organizes data types. Because understanding this is the key to use the right type in the right place. So Verilog classifies data types into 2 broad classifications. First, we have nets. So these represents the physical connections between components like wires on PCB and connections inside the chip. So nets are used in structural modeling and are typically assigned values using the assign keyword. Then we have variables. These are used inside the always or initial block, that is procedural code. So unlike nets, variables holds value and you can update them conditionally using non-blocking or blocking assignment statements. So depending on what you are modeling, a connection or a stored value, you will choose either a net or a variable. And now let's dig deeper into nets, starting from the most fundamental one, wire. So here is the clear breakdown to help you decide should you use a net or variable. So nets like wire OR are meant to represent connections. So they are just like actual wires on the circuit. You cannot assign them using a procedural code. Instead, they are used with the assign keyword for continuous assignment. On the other hand, variables like reg or integer are used when you need to store or update a value, especially inside a procedural blocks like always or initial. Another key difference is nets default to Z, that is high impedance if not driven. The variables on the other hand, they are default to unknown, meaning undefined, so which helps catch bugs during a simulation. So when you are connecting gates or modules, use net. When you are modeling a logic that involves state, memory or control flow, use a variable. Next, let's explore the most basic and widely used net data type, that is wire. So wire is the most basic and widely used net type in a Verilog. It acts like a physical connection between 2 points, just like real world wiring in a circuit. So it doesn't hold or remember a value. It only shows whatever is driven onto it in a real time. So you cannot assign a value to a wire inside a procedural block. Instead, we use continuous assignment statements like assign y equal to a and b. Now, here's something important to remember. When you declare an input in a module, it is by default treated as a wire. The same applies to the output ports, unless you explicitly declare the output as a reg. So this is why most of the time you will be using wire to connect gates, modules or describe a combinational logic. Now let's move on to slightly more interesting net type, that is wire OR. Wired OR is a very handy net type when you expect multiple drivers to contribute to the same signal line. Unlike a normal wire, where multiple drivers creates conflicts and results in an unknown, the wired OR resolves the conflict using a bitwise OR logic. This means all the drivers connected to the net will be ORed together. Let's say one driver puts a value A, another puts a value 0. So the result will be 1. If both put 0, the output will be 0. If both put 1, then the output will be 1. It's often used in arbitration logic where multiple modules try to assert a shared signal, and the open drain or open collector logic modeling, and in bus resolution when many sources drive a status or a flag light. One thing to note is that wired OR is rarely used in synthesis. It's primarily for simulation and behavioral modeling. So you won't find it in most RTL code practices. Next is wired AND, and it is very similar to wired OR, but it resolves the multiple drivers using a bitwise AND logic instead of OR. So if we have a multiple blocks or modules assigning a value to the same wired AND net, Verilog will combine all those values using an AND operation. For example, if one driver output 1 and another output is 0, the final result will be 0. The output will be 1 if all the drivers puts the value 1. This is particularly useful when you are modeling acknowledgement line or open drain behavior, and then also where multiple control blocks need to cooperate, and only when all of them agrees the output should be high. So just like wired OR, the wired AND net is also rarely used in synthesis. It's mainly for simulation or high level modeling where multiple drivers logically AND their intent to the single wire. Now that we have seen how wired AND and wired OR resolve signal conflicts, let's take a look at one more net type that supports high impedance control, that is trireg. Trireg is a tri-state net with a memory. It behaves just like a trie, allowing multiple drivers and high impedance states, but with one key difference. That is, when no one is driving the signal, that is, all drivers assigned to high Z, this trireg holds the last driven value instead of going into high impedance. Think of it like a capacitor that stores charges. So once a value is driven, it stays until someone updates it. For example, trireg data, and assign data equal to if enable high, then assign value 1 or else high impedance. So from this logic, when enable is high, then we actively drive the signal. When enable is low, the line would usually go to high Z. But since it is a trireg, it simply remembers the last driven value. So the output will be 1. This is useful for simulation to model things like bus hold behavior, passive storage, and open bus systems. Again, this is for simulation only, not synthesizable in RTL. Alright, we have covered a lot in this video. We looked at some of the key net types in Verilog. We understood how they behave when multiple drivers are involved and how Verilog resolves those values depending on the type of net. This understanding is crucial when you are simulating complex digital systems. So in the next video, we will move to ModelSim simulation and actually observe how these signals behave when multiple drivers are present. And there, we will explore how wire OR and wire and trireg differs in the simulation environment. So stay tuned until the next video comes. Don't forget to subscribe so that you won't miss the upcoming videos. See you in the next video. Bye.